There are two more versions of the trigonometric Pythagorean identity, and they can be derived from the main Pythagorean identity, cosine squared plus sine squared equals 1, by dividing this identity by either cosine squared or sine squared. So, for example, if you start out with cosine squared t plus sine squared of t equals 1, and you take this equation and you divide throughout every single term by cosine squared, divide by cosine squared here, and divide by cosine squared here. Then, and you simplify, what you would get is the following. So canceling here, you would get a 1. And sine over cosine is tangent, uh, but it's squared, so you have to put tangent squared. And then 1 over cosine is secant, but it's squared, so you put secant squared. And that right here is another version of the Pythagorean identity. If you start it with cosine squared plus sine squared equals 1, and you divide it instead of by cosine squared, if you divide it by sine squared, you would get yet another form of the Pythagorean identity, and this is the one you would get. So these two equations right here are two other versions of the Pythagorean identity. All of them are called the Pythagorean identity, although the one that says cosine squared plus sine squared equals 1 is usually the one that goes by that name. So when you say the trigonometric Pythagorean identity, usually this is the one that people are referring to, or the one that comes to mind. But these two are also other versions of the Pythagorean identity, and they can be called the same. Now, these two versions of the Pythagorean identity have the same uses, or can be used in exactly the same way as you use this one. Exactly the same way. No difference. So, here's an example. Suppose that I give you the secant of t and tells you that's negative 17 over 8, sorry, uh, and ask you to find t, well, you use it exactly the same way. So if I give you one of these, you can find the other one, right? If I give you the secant, you can find the tangent, or if I give you the tangent, you can find the secant. Similarly, if I give you the cosecant, you can find the cotangent using this version, or if I give you the cotangent, you can use that cosecant. All right, so let's do this example. So I know that the secant is negative 17 over 8, and I'm asked to find the tangent. So I'm going to use this formula. So starting with this formula, with this identity, we're going to find the tangent. Well, I'm going to plug in here, negative 17 over 8, and we're going to have 1 plus tangent squared of t. Now, we're going to simplify this. 1 plus tangent squared of t, and then you square the top, square the bottom, you get 64. If you square the top, what do you get? Okay, let's put it here. So we get 17 squared. Where's the square button? So you get 289. Okay, 289. Okay, then move the 1 to the other side. We're gonna get tangent squared of t equals 289 over 64 minus 1. If you're doing this by hand, this would be 289 over 64 minus 64 over 64. So you subtract across the tops. And 289 minus 64 is actually 225 over 64. And now, finally, take square root on both sides. And we're going to get tangent of t equals plus or minus square root of 225 over 64, which simplifies to square root of 225, I think is 16. Let me double check that. Square root of 25. Okay, yeah, it's 15. And then square root of 64 is 8. All right, so this is what we get. So that means there's two possibilities. Either tangent is 15 over 8, or tangent is negative 15 over 8. We have to decide which one is it. Okay, they're telling us that that the angle is between 0 and pi. The angle is between 0 and pi means it is either in the first or second quadrant. It's in the upper half of the plane. Between 0 and pi means the angle is here, somewhere. Could be there or could be there. And with that, I'm supposed to decide whether it should be this one or that one. So you have to think then in which quadrants, what is the sign? If I know that the angle is in the first or second quadrant, what is the sign of tangent in those quadrants? Tangent will be positive here because both coordinates are positive here. Both sine and cosine are positive here. And since tangent is sine over cosine, positive divided by positive is positive. So for tangent is positive on the first quadrant. And on the second quadrant, tangent is negative. On the third quadrant, tangent is positive because both are negative. And in the fourth quadrant, tangent is negative. Okay, so I know that the angle is in the upper half. So this is what they told us. The angle is between 0 and pi. So that means the angle is either here or there. But that doesn't help too much because if it is there or there, it could be positive or it could be negative, which is what I still have. So that doesn't help us decide. So what to do then? Well, in that case, we're going to use then the other piece of information again. We already used it. We're going to use it again to decide whether it should be the positive or negative. The secant is negative, but the secant is 1 over cosine. So the secant is 1 over cosine. Okay, that's the secant. The secant of t is 1 over cosine. And I know that the secant is negative. So if the secant is negative, it is negative 17 over 8. If the secant is negative, what does that say about cosine? Well, the top is positive, and that means the cosine has to be negative. So if the secant is negative, the cosine has to be negative. So now when I have a little bit more of information, I know that the cosine is negative. The cosine is the x-coordinate. Cosine is the x-coordinate. So now I know two things. The angle is either quadrant 1 or 2, but also the x-coordinate is negative. With that, I can definitely conclude that it has to be this quadrant. So if it is in that quadrant, the tangent is negative, and that means this is the right answer. So the right answer is this. Okay? And that's how you decide that. Now, changing topics. Another property of trig functions that you should know is the even and odd properties of trig functions. So recall from college algebra that a function is said to be even if when you plug in a negative x and you simplify, you get the original function, f of x. So in other words, from the point of view of algebraically, it is easy to think about it as saying like if the function ignores a negative sign inside. So if you put in a negative number, is the same as if you had plugged in a positive number. Okay, so f of negative x equals f of x. So f of negative 5 will be the same as f of 5, for example. All right, so, or you can say that negative sign is ignored, right? You can drop it. You can drop it and simplify by dropping the negative sign. So that's an even function. And also remember that a function is said to be odd if whenever you do the same, plug in a negative number, the negative sign is pushed out. So basically, the function uh, spits out the sign. So you move it out. Okay, you move it out. So f of negative x, after you simplify, is the same as negative the original function. So the even function, like you can drop the sign. Odd functions, you can push out the negative sign. So that's even and odd. So it happens that the 6 basic trigonometric functions, all of them are either even or odd. And the story is all the trig functions are actually odd except 2 of them. And those are the cosine and its reciprocal. The cosine and its reciprocal are even functions. The rest are odd. And here's a quick story of why that's true. So let's explain why that's true. So let's draw a picture real quick of the unit circle. And let's draw an angle, again in the first quadrant for convenience. Okay, so let's say this is our angle T. Then if that's our angle T, this is the coordinates of the point of intersection between the terminal side and the unit circle, then we know that the coordinates of that point, you can express them in terms of trig functions in terms of the angle T, and the x is just the cosine, and the y is just the sine. All right. Now, if you consider the angle negative T, well, the angle negative T, you would draw it. It would be exactly the same width here, but you measure it in the opposite direction, right? Positive angles are measured that way. Negative angles are measured this way. So that would be the angle negative T. Now, in terms of coordinates, what would be the coordinates of that point? Well, in terms of trig, it would be the cosine and the sine, but of that angle. So this would be the cosine of negative T and the sine of negative T. Now, in terms of x and y, this should be the same x. However, the y should be the opposite y. It's the same x because it's the same horizontal displacement from the origin from left to right. Same x, but the y is opposite. And this should be like a reflection, okay? It's a reflection through the x-axis. All right, so now we compare. If we compare, you see the x and the x is the same. So that means the x coordinate is the same, but the x coordinate is cosine of t for that point, and the x coordinate is cosine of negative t for the other point. But these are supposed to be equal, same x coordinate. So what does that mean? That means that cosine of negative t equals the cosine of t, and that means the function is even. This holds actually for every angle. And then if you compare now the y coordinates, what do you get? This says that this coordinate is the opposite of that one. This coordinate is a negative of that one, right? This one is negative of that one. So comparing, that means that this one is a negative of that one. In other words, this one is a negative of that one. And that is precisely the statement that sine is odd. So cosine is even, sine is odd. Other functions can be analyzed more easily by using identities, such as, for example, tangent. How about tangent? Tangent of negative t, well, this is the same as sine over cosine. Sine over cosine. We just said that sine is odd, so it pushes out to the negative. And we just said that cosine is even, so it will drop to negative. And this is precisely tangent. So you will get this is equal to negative tangent of t. So that means tangent is odd. Tangent of negative t equals negative of tangent of t. And I'll do one more, but all of them can be analyzed the same way. How about secant? Secant of negative t. This would be what? This would be 1 over cosine of negative t. But cosine, we just said it is even. So cosine will drop that negative sign. So this is cosine of t. And 1 over cosine of t is the secant of t. So you see, secant of negative t is the same as secant of t. So that means that secant is even, and so on. So all the trig functions are odd except actually cosine and its inverse. Those are the only ones that are even. All the other ones are odd. And you can use this fact to simplify things. When you're dealing with negative angles, you can get rid of the negative sign by dealing with it. You can deal with it by using these properties, sine of even and odd. So for example, if I had to deal with sine of negative 40, I can just use the properties of sine and cosine to simplify this and say, well, sine is odd, so that's going to push out the negative. So that is the same as negative sine of 40. And now I have the same expression but with positive angles instead. How about cosine of negative 10 degrees? Well, same idea. I have to remember that cosine is even. The cosine is even, you can drop that sign and say that this is cosine of 10 degrees instead. Simplify it that way. And of course, it doesn't matter if the angle is in degrees or radians, it still works. Tangent of negative pi over 5, well, tangent is odd, so that negative sign is pushed out, and this will be negative tangent of pi over 5. And lastly, secant. Secant is even, so that's going to drop that negative. So secant of negative pi over 4 is the same as secant of pi over 4. Okay, and that's how you can use the properties of even and odd to simplify trigonometric expressions when you have negative angles. Another property that you should be familiar with is the cofunction identities. The cofunction identities. So what are the cofunction identities? Well, it turns out that the 6 trig functions can be paired up with each other, not only by means of their reciprocals, but also by means of their cofunctions. So this is what happens. If you start out with, let's say, for 90-degree angles, for acute angles, for angles between 0 and 90 degrees. If you consider the corresponding triangle associated to a given angle that is between 0 and 90, you draw that triangle. Okay, you can draw it like that or like that. And then you apply, let's look at it from this side. And you apply SOHCAHTOA to this, you're going to get something surprising. So let's say this is alpha right here, and that is beta. But beta actually is 90 minus alpha, right? So for example, if this was 25, or if this was 20, we would know that this has to be 70 because they both add up to 90. If this was 10, it would be 80. If this was 15, it would be 75, and so on. So if this is alpha, this would be 90 minus alpha. They're complementary angles. Okay, so now let's apply SOHCAHTOA to both angles. If you apply SOHCAHTOA to this angle first, let's start with sine. What would you get? Sine of alpha, and we have to give these sides a name. So let's call this one x and this one y and this one h for hypotenuse. You're gonna get you're gonna get so opposite, which is x, over hypotenuse. So katoa. Now let's apply cosine. We're gonna get cosine of alpha. So ka adjacent. So it will be y over hypotenuse. Okay, that's what we get. And now let's apply same, but with respect to this angle, from the point of view of this angle. So what do you get? You get sine of 90 minus alpha will be so opposite is y over hypotenuse. And then applying cosine, we will get what? So ka adjacent. So cosine of 90 minus alpha is adjacent over hypotenuse. And now if you see, these two things are the same, and the other two are the same. These two are the same, are exactly the same. So in other words, that means that sine of alpha equals cosine of 90 minus alpha, and that cosine of alpha equals sine of 90 minus alpha. What this basically says is that if you start with sine, you can change that sine to a cosine, provided that you change also the angle to the complementary angle. The same thing if you start with cosine. If you start with cosine, you can change that cosine to a sine, provided that you change the angle to the complementary angle. And this relationship is sometimes referred to as saying that sine and cosine are cofunctions. And the word co is how you determine whether a trig function is a cofunction of another trig function. So for example, then, so you see the sine can be paired up with the cosine as its cofunction. The tangent can be paired with the cotangent as its cofunction. And then the secant can be paired with the cosecant as its cofunction. So the cofunction of secant is cosecant, the cofunction of tangent is cotangent, the cofunction of sine is cosine, and the other way around. The cofunction of cosine is sine, the cofunction of cotangent is tangent, the cofunction of cosecant is secant. So this is how they are paired up in terms of cofunctions. A function and its cofunction. And for each of these pairs, the analogous equations hold. So I have listed them all here. Okay. The first 6 right here are those for each pair. And that's for if you're using degrees. Remember that if you're using radians, you have to put not 90, you have to put pi over 2 because pi over 2 is 90. So let's do an example like that where we use these identities to rewrite things. So rewrite the following expressions in terms of an appropriate cofunction, of the appropriate cofunction. So this one says secant of negative 40. Well, the cofunction of the secant is a cosecant. So this is going to be the cosecant. And I can pass to the cosecant provided that I pass to the complementary angle. This is in degrees, so this is 90 minus negative 40. And then we simplify this. This is the cosecant of, if you simplify that, that's 130. Right, so secant of negative 40 degrees is the same as the cosecant of 130. How about this one? The cosecant of 10 degrees is equal to what? Well, the cofunction of the cosecant is the secant. So this is a secant, the same as a secant of 90 minus 10 degrees, passing to the complementary angle. And simplifying, this is the same as secant of 80. Okay, now let's do it with tangent. The cofunction of tangent is cotangent. So this is the same as cotangent, and then because we're using the radians, it's not going to be 90, it's going to be pi over 2 minus pi over 5. And then, of course, we have to simplify that. How does that simplify? Well, the common denominator is 10. There's the least common denominator. And then to get a 10, I multiply by 5, top and bottom. So the top is going to be 5 pi. And here I need to multiply by 2. So the top is going to be 2 pi. And then now we can simplify. 5 minus 2 is 3 pi. So 3 pi over 10. Okay, now you should pause the video and attempt the next two. Rewrite these expressions in terms of their cofunctions. Okay, assuming that you did that, let's do it now. So the cofunction of the cosine is the sine. So this is the sine of pi over 2. So if you pass to the cofunction, you need to pass to the complement. So pi over 2 minus pi over 4. And that is just pi over 4. So just notice that the cosine and the sine for pi over 4 is exactly the same. Pi over 4 is a special angle, so if you remember from the table, that's the only angle for which both the sine and the cosine is the same, namely square root of 2 over 2. You should memorize that. It will help. All right, and then lastly, rewrite this one using the cofunction. Well, you can pass the cofunction of sine is cosine, so you can pass to the cosine provided that we pass to the complement. So this would be 90 minus 270. So this is going to be what? This is going to be, what is 90 minus 270? This is cosine of negative 180. Okay, so that's correct. Now, if you want to simplify this more, it's a special angle. Okay, so typically we could look it up, but we're going to deal with that in a moment. You can use the properties of even and odd to simplify this further and say this is because cosine is even, this is the same as the cosine